In the last video, we made this circle of cubes. Okay, so we started at radians of 0, and then we increased radians by 0.1 and by 0.1 and then by 0.1. And each time radians changed, we recalculated the x and y using cos and sine, and then made a cube there. That's what this code is from before. So now we're going to do something we're going to make another interesting shape, and maybe you can guess what it is when we start working on it. We don't need update. First, I want to lay down this circle on the floor, the ground that we're on, okay? Instead of having it standing up. So click on the floor, make it at 0, 0, 0, and the player should be at 0, 2, 0. Now in the code, we're just going to switch the x and the z, or the y and the z, and save it, and now press play. Okay, so it's laying down, that's good. And I'm going to make the y start at 0, so it'll be on the ground. So what we want to do now, actually, y is stuck at 0. What if, I press play, what if, so this is the first cube, let's say, then it makes this one, and then it makes this one. What if each time it makes a cube, we increase height by, something like 0.5? So every time we make a new cube, y increases. So instead of float y is 0, up here, float y is 0. And instead here, y equals y plus that. And the f is because it's a decimal. You just have to write that in the C#, the language we're writing this in. So save this and press play. Okay, so that's cool. Now maybe this is inspiring you a bit. You might understand where this is going, but we're going to make a DNA spiral. So that's what these look like. It's a double helix. So right now we have one helix and it's only one turn, but we're already pretty close. So again, if we look, and actually I can't look up that much. Click on the player, scroll down to the bottom to mouse look, and change minimum y to -80 degrees and maximum y to 80 degrees. Press play. Now we can look straight up almost. That's better. So it's only doing one turn. So that's one problem. Why is it one turn? Why isn't it half a turn or 5 turns? Where's that coming from? So if we look at our code, radians right here, what this means is radians will be between 0 and pi times 2. So in the unit circle, we'll start at 0, and of course we start turning around this way as we add radians. So this up here, we're at pi, that's 1 pi. And if we keep going, it's 2 pi. That's 1 full turn. Because half a turn is pi, or a quarter of a turn is pi over 2. Pi is just a number. So pi over 2 is about 1.5 right here. So after 1.5-ish radians, we'll be at this point. And it's just like degrees. So after 180 degrees, or pi radians, we'll be here. So in this code, we're doing 2 pi. That's why it's 1 full turn. So if I do pi times 2 times 6 and save it, we're now going to have a lot more. We're going to have 6 loops, loop-de-loops. So that's more spirally like. Now there's one last thing we need for a DNA, it's a double helix, right? This is only one helix. We actually want over here, and geez, this player is slow. Come on. Come on. Right, yes, right about here. This is where we want another cube, just like over there, to start spiraling out from here. Well, how are we going to do that? We're actually going to make a cube again, just like this, except we need to change that xyz again. So we're going to recalculate it. And the difference, oh, get rid of float, because we're not making a new variable anymore. We already have x. Oh no, what am I doing? Jeez. Copy this line again. Okay. And I'm going to get rid of this, get rid of this. So x and z are up here and they work. But we want to recalculate x and z as if radians were an extra half turn around the circle. So half a turn around a circle, like I said, was pi. So we're just going to add pi to those radians. Math.pi. Okay, and then we're just going to make another cube at those new x, y, z coordinates. I'm going to save it, press play, and there's our double helix. Okay, my player is so slow. This is killing me. Click on player, go over to character motor, movement, max forward speed 9, max sideways 6, backwards 6. There you go. There, now we can move. All right, so there's a double helix. There's two bases for it. And that's just like DNA, just millions of times shorter, I'm sure.